ahead and start recording this. So we're starting in module 2 here. So, yep, Shannon, you're good. No background noise coming from anybody today. Everybody is muted, so that's good. So make sure if you want to talk, go ahead and unmute yourself. And Shannon, feel free to unmute and talk even if your dogs are barking if you have a question. But thanks for checking in. All right, so let's go ahead and get started.
Yeah.
Hey, there's Jimmy. All right. So yeah, we're good. We're going to go ahead and get started. One thing before we jump into the actual material is that
Okay. Yeah.
Jamie, I need you to mute yourself because you're talking to people in the background. Can you hear me, Jamie?
Well, and what you can do is too, because maybe don't use, when you give your reasoning, you don't even have to really say anything about getting on the floor because I don't want to, but.
Okay, so Jamie, I just muted you because you were talking to other people, but we could all hear you. So you have been muted by me. You cannot unmute yourself. Okay. Anyway, back to this. Announcements. I post things in the announcements because I think you will benefit from them. So read those announcements. I think I got 8 emails from people in this class asking, how do I get into web work? Which is a legit question because you need to get into web work, right? But I posted a video about that. And I think that was in the original email of, hey, there's a video, so watch that. There were 2 videos that I posted about section 2 homework. And then I got emails. I don't understand this problem. Okay, look at the announcements. So we're still at the beginning of the semester, so we're kind of getting the feel for this. But announcements are things that don't go away. So if I email you information, emails are things that it's easy for you to hit delete or to lose because I'm sure you get a ton of emails. I know I do. Things get lost in there all the time. But when I post an announcement, you can't delete that. It's always there. So I want you to kind of make that a daily thing. Check your announcements, just see if there's anything new. I posted an announcement today about section 5 homework. There are 2 problems that I get a lot of questions on. I posted the videos for those. So before, and I'm not saying don't email me because please do, but check the announcements first. It's going to save you time because if you email me a question that I've already answered in an announcement, right, then you wait for me to respond back. Your time is being wasted, and that's one thing I don't want to do. That's why I try to post these announcements so we can kind of get the questions answered before you ask them so that it can save you time. So always go double check your announcements first. That's super, super important. Okay, so this week, Module 2, we have 3 sections in web work, 3, 4, and 5, a quiz that goes with those, and then, of course, your discussion board. Same as last week. As soon as you finish this live session, if you have time, go and finish that discussion board. So you always want to kind of do those. They're easy points, those discussion boards. There are no right or wrong answers generally. So it's a matter of doing them, talking to your classmates in that way and getting it done. So make sure you get that done. You want to get as many points as possible, and discussion boards are an easy way to do that. So again, a pretty light week. You might say 3 web work sections is not a light week, but there's not a ton of problems in those sections. And I think that you'll find that they'll go pretty quickly. If you do have questions, let me know. We'll go from there. So, okay, let's go ahead and jump in to these 3 sections. As usual, you interrupt me verbally or in the chat box. If you have questions, comments, concerns, or whatever, and we'll go from there. So section 3 spends a lot of time talking about big numbers. Small numbers are more so in section 4, but that's what scientific notation is all about, right? Writing big or small numbers in a different way. So we're going to do a little bit of work with scientific notation in this section, and it's helpful because we're going to use these skills throughout the rest of the class. What did I just hit? Okay, before we get into how to write scientific notations, there's one thing that I want to draw your attention to. Now, if you watch the first video from section 3 in your packet, which I encourage you to watch the videos that go with the packet, but there's a big takeaway from this section, and that is the numbers that are associated with certain words. So we get thousands, We're dealing with million, billion, and trillion. So these 4 words have numbers that should associate with them. So like if I say 6,000, what number comes to mind when you hear the word thousand? Anybody have a number that comes to? So if I would say 3,000, I would no S on the end of that, right? I would write that as 3 with 3 zeros. So generally when we talk about, when you see the word thousand, the number 3 is what should come to mind. And we're going to get into that. What does that mean with scientific notation? We'll get to that in a minute. But when I say 3 million, well, that would be a 3 with 6 zeros. So when I see the word million, I should think 6. When I see the word billion, I should think 9. And trillion should be 10. Excuse me, 12. I don't know why I said 10. So 3, 6, 9, 12, you see these are multiples of 3. And if you watch the first video that goes with this section, you will see why that's the case. It goes through that in detail in that video. So I would recommend you watch that video for more details. But that's kind of a big takeaway from this section, is being able to work with these big numbers from words and then moving them into a workable format. So how do we write scientific notation? That's kind of the other piece to this section. Well, scientific notation is a number times 10 to another number. And this is probably something that you've done at some point, but if it's been a while, well, you might have forgotten, right? Math is something, if you don't use it, you lose it. And I don't know the last time I've used scientific notation. So there are a few rules that go with this, right? The first one is that the number in front here must be between 1 and 10. So you always want to see that number in the front is between 1 and 10. Now that means it could be a whole number like 4. 4 is between 1 and 10, and that would be fine. But it also could be a number like 9.6 or 3.12. You'll notice that in all of these, including in the 4, the number in front of the decimal point, there's only one non-zero number in front of the decimal. So that's important to recognize. Then the other piece that we need to talk about is the exponent. So when I'm talking about this exponent, the exponent is either going to be positive or negative. You will have a positive exponent if you have a big number. And that's hard to quantify generally. But in this case, a big number means greater than 10. Your exponent is going to be negative if you have a small number. And a small number means less than 1. So you can see that this front number has the parameters of between 1 and 10. And anything outside of that, right, bigger than 10, we call a big number, positive exponent. Smaller than 1 means a small number, and that's a negative exponent. And we'll reiterate these things as we work through. As you watch the videos for this class, or for this section, you will notice that as well. All right, so, and we get more into scientific notation in section 4 as well. So that's just kind of your intro piece. All right, let's go ahead and start playing. So the first thing we're going to do is we're going to do some conversions. So we're going to convert standard form to scientific notation and scientific notation to standard form. Standard form is the form that we generally live with. You know, normal people use numbers in standard form. So when you look at this first problem, you have 320,000 in turn. That's a standard form number. We want to change that to scientific notation. Well, as you notice, right, scientific notation is about a number between 1 and 10. Well, when I first look at this, I noticed there is no decimal point. So remember, if there's no decimal point visual, it comes at the end of the number. So right now my decimal point is after the last 0. To make it scientific notation, I need my first number between 1 and 10. So I want to move my decimal point to be between the 3 and the 2, because that will give me 3.2, which is between 1 and 10, exactly what I want. Okay, so then I'm going to have the times 10 to the, okay, well, what is, wrong button, what is my exponent going to be? Well, you just need to count. So if you can count, you're going to love this. So you're at where your decimal starts, which is my blue dot. How many positions did I move to get to my blue line? So where did it start versus where I want to end it? So you just count 1, 2, 3, 4, 5. It moved 5 places, so my exponent is 5. I know it's going to be positive because 320,000 is a big number, right? It's greater than 10. Anything greater than 10 has a positive exponent. So that is the conversion to scientific notation. Now, if you look at the second problem, now we are given scientific notation, 1.75 times 10 to the fourth, and we want to change that to standard form, which is the way that we talk in normal life. Well, you look at your exponent. Your exponent is a positive 4. Remember that positive means it's getting bigger. Well, for my number to get bigger, my decimal needs to move to the right, and it's going to move 4 positions. So I have 1.75. If I move it 4 positions, 1, 2, 3, 4. What goes in those empty humps, as I call them, or divots? I don't know, call them whatever you want.
It would be zeros, wouldn't it?
They would be zeros, exactly. So we add in the zeros, so our answer would just simply be 17,500. So anytime you're going from scientific to standard and you're moving it, if you have empty humps, as I call them, you fill those in with zeros. All right. Okay, I want you to try two, and one of them is going to be a little bit different than what we just did, but that's okay. All right, so I'm going to give you a minute or so and see if you can change those two. Okay, so your minute is up. In this first one, you might have, there's more than one way to do it. So one way is to say, okay, it's million. I could write that out in standard form first and then change it to scientific notation. And whichever way you did it on your paper, if you got the right answer at the end, is the best way to do it, because whatever way your brain works. But I do want to show you, I don't know if I call it a shortcut, but it's the way that my brain sees this problem. So goes back to million. If you recall from the first slide here, whatever, million means 6. So this is the same as 43.4 times 10 to the 6th, because million is 6. However, that is not scientific notation. So I'm not done at this point. 43 is bigger than 10. So because it's bigger than 10, I know that I need to change it. Bigger than 10 means my exponent is positive, right? Goes up. Positive goes up. It's like adding. So I need to move this decimal one place over, and because it's big, my exponent would get bigger by 1, right? One place goes up by 1. If I had moved it 2 places, it would go up by 2, so on. And I end up with 4.34 times 10 to the 7th. And if you had done it the other way, you probably would have gotten the same answer, okay? So that's answer for the first one. Second one, you should have just moved your decimal right 3 places, so 1, 2, 3 places, and you end up with 3,580. Any questions on this page? Okay, that's pretty much section 3. I do have 2 more problems from section 3 that if we have time at the end, I have them at the end. But if we don't, they're in the video, so you can always catch them there. So we'll see how the rest of this kind of works through. So section 4 is per capita. Does anybody know what per capita means? because this is also a concept that you're going to see throughout this course.
Or would it be like per a certain thing, like a certain object
It is.
that you have?
Yes, and Julie in the chat box, I don't know who was talking. I'm sorry, I didn't see whose voice popped up. But it is per a certain thing. And as Julie mentioned in the chat box, capita means people or person. So when you see something that says per person or per capita, it means per person. You're dealing with people every time. So you could have TVs per capita, Tic Tacs per capita, key fobs per capita, iPads per capita, anything. So basically, we're going to deal with a thing, something per person. So you're always going to be dividing by the people. The people are always on the bottom. And whatever it is you're talking about goes on the top. And remember, we talked about this, I think, last week, that the word per implies the fraction bar, which is why you will have per person. Because capita falls after the word per, it goes on the bottom. So when we're looking at this first example, if there are 240 TVs in my family and 78 family members, how many TVs per capita? Well, if you look at this little phrase, per implies the fraction bar. TVs come first, so we're doing TVs. Capita means people. So if you think about it in words, sometimes it's easier if you think words and then let the numbers kind of fall where they may. And then we just fill in. Well, there's 240 TVs. So my numerator is 240. I have 78 family members. Generally, we call those people. Not always, but generally. So there's my fraction, 240 over 78. Unfortunately, and Julie wrote this in her chat box perfectly, it's per person, so generally it's per one. So we want to simplify this fraction. We want to turn it into a decimal. So how do I turn 240 over 78 into a decimal?
Just divide.
Exactly, Shannon, exactly. So we want to divide, right? 240 is on top, so we're going to start with 240, divide by 78. Let's go and round to 2 decimal places, if you would. So when you take 240 divided by 78, round to 2 decimal places, how many TVs per family member do we have?
3.08.
3.08. So if you were writing a meaningful sentence for this, you would say, in my family, we have approximately 3 TVs per person. That seems like a lot of TVs for one per person, but it is what it is. Okay. Hopefully that process makes sense. I want you guys to try one. See what you can do with this one. Give you a minute or so. All right. Let's see. see where you're at. What'd you start with in this problem? Anybody want to take a gander?
Did you say how many decimal places you want us to go to? Or did I miss that?
I didn't say. No, it doesn't really matter.
Okay.
Whatever you do is fine. We're looking at concept right now, not so much rounding rules. Man, that's a really straight line. But we're talking about blue pens per capita, right? So you should be having blue pens, and we want people on the bottom. So I have 23 million blue pens. That's pretty accurate for how many I have in my office. And the number of people is 540,000. What did you do from here? Because there's a couple different ways you can attack this mathematically from here. Okay, so Julie typed in the chat box. She changed 23 million to scientific notation and did it flawlessly. 2.3 times 10 to the 7th. Justice said, I canceled out the zeros. Yes, that is another fabulous first step. There's so many different ways you can go, and as long as it's mathematically sound, right? Going to scientific notation, canceling out zeros, both fabulous options. I recommend both of them. Yeah, if we're going to go scientific notation, since that's what I started writing first, what is 540,000 in scientific notation? Okay, so there it is, 5.4 times 10 to the 5th. And this actually helps. So this division problem is also centered in section 3. So we can do it in section 4, and then, you kind of practice a little bit. Okay, so we're dividing. So when we're dividing, right, we first start by dividing these front numbers. So if we take 2.3 divided by 5.4, we are going to get a number, something like 0.426. Right? Top number is smaller than the bottom number, so it's going to be less than 1. What do I do to my exponents? This is exponential rule. If I have the same base for my exponent and I'm dividing, what do I do to these exponents? Subtract. Fabulous. Somebody remembers their exponential rules. Good. So we're going to divide, which means we subtract 7 minus 5. My exponent is 2. Now, the one thing in math in general that people tend to forget is that logic and common sense needs to be a part of your world. If somebody said, how many blue pens do you have? None of you would say 0.426 times 10 to the second, nor would you answer that in scientific notation of any type. If somebody says, how many blue pens you have, you would say, I have 36, I have 1, I have 5. Right? You would give them a number. So make sure when you're reading these story problems and you're doing, answering these questions in terms of like the exam or homework or whatever, you kind of don't lose your common sense, I guess is what I'm telling you. So if my exponent is 2, I'm going to move my decimal over 2 places, and I end up with 42.6 blue pens per person in this town. Now, you might say, well, I can't have 0.6 of a pen, and you would be correct. So you could round up, because 0.6 rounds up, and say there's approximately 43. Or you technically could round down because you don't have 43 full pens, you would just have 42. Either one of those would be acceptable. Okay. Question about the per capita concept. As long as you remember that it's always per person and the people is always on the bottom, you're golden, right? Other than that, it's a ratio. And you played with ratios last week. We're going to continue to play with ratios, and that's what it is: being able to simplify a ratio. Okay, using your knowledge from section 3. I want you to see if you can do, this is scientific notation with smaller numbers. See if you can wrap your head around what we did in section 3 like 10 minutes ago. Now we're dealing with small numbers, negative. So I'm going to give you about a minute. See if you can answer these 2 questions. All right. Anybody come up with an answer for that first one, changing that super small number to scientific notation? Excellent. So I know that people watch the video can't see the chat box, so we'll talk through it. That is answers correct, Vanessa and Justice. Very good. So remember, scientific notation, we want the decimal to be between 1 and 10. So we want to move it so that we have the 2.3, as you guys noted. And then this is small, right? Less than 1, so I know my exponent's going to be negative, and you count 1, 2, 3, 4, 5, 6 places. So we end up with a -6. Very good. In number 2, I should have numbered these, I did not, right? The negative exponent says my number is getting smaller. Smaller means my decimal is going to move to the left 3 places. 1, 2, 3. What goes in those humps? Zeros. One thing to remember is that don't forget your decimal point. I have a lot of people who add the zeros to the beginning but forget the decimal point, and that kind of defeats the purpose. Web work is sometimes finicky. When you have a small decimal, it will sometimes require the 0 in front of the decimal point. So with these, you might want to be careful and make sure you add that 0 in front. Okay. Any questions about the concept of per capita or dealing with scientific notation using small numbers instead of large numbers? Because that, my friend, is section 4. And again, this is very abbreviated, right? I mean, in class, we spent an hour and a half on section 3 doing just a lot of repetition, a lot of story problems in my face-to-face class. So we spend about the same amount of time on section 4 and section 5. So we're really doing 4.5 hours worth of discussion in face-to-face class in about 45 minutes. So obviously there's more in the packet than what we're discussing, but we're doing kind of an overview. Okay, so I want to jump into section 5. I believe we have a few more examples in section 5. Yeah, not many more. But we're doing super good on time. Do you remember back in your mathematical days of some type, solving proportions, right? A proportion in itself is comparing two ratios. Ooh, Justice loves proportion. Me too. To me, proportions are well, I like them because you solve every proportion the same way. So once you understand how to solve them, you're golden. You do have to be able to set them up in this course, but proportions by definition are a comparison of two quantities. And in this case, they're two ratios. So you'll notice that we have two fractions. Fraction is the comparison, a fraction is a ratio. So we're setting two ratios equal to each other, and we're gonna find the missing piece, and it could be who knows what. The majority of the problems in this section are story problems, right? There's words involved, so they're more application problems. This first page is just so that we remember how to solve them, or we learn how to solve them, because it's great if you can read the story problem, but if you don't know what it should look like when you set it up, right? It should look like a fraction equaling a fraction, and then how to solve it, well, then you're kind of out of luck anyway. So does anybody remember, if we're given a proportion, right, a fraction equaling a fraction, how do we solve that? The cross multiply, exactly. Why does it keep doing that? I must be hitting a button today, and I don't know what it is. I don't know how to fix it. Anyway, okay, so we're going to cross multiply. Yes, that is what we're going to do. So cross multiply means you take the numerator of one fraction and you multiply by the denominator of the other fraction. So when I take x times 3, right, I don't know what the value of x is. So x times 3 will give me 3x, right? 3 times some value of x. That's going to equal the numerator of the other side times the denominator of the other side. That's why it's cross multiply, because you're kind of making a cross here. So now on this side, we have 2 times 12, which we all know is 24. So I have 3x equals 24 as my first step in solving a proportion. Using our awesome skills, what is my next step? After I cross multiply and I write out my equation, I have 3x equals 24. What is my next step?
Divide both sides by 3.
Divide both sides by 3. Remember that in an equation, the equal sign splits it into half, right? Math is all about equality. Whatever you do to one side, you have to do to the other. So because the x is what we want to get by itself, this is like 3 times x. So the opposite of times is divide. We call those inverse operations, in case you cared. When you divide by 3, 3 divided by 3 is 1. So I end up with 1x equals 24 divided by 3. Last time I checked is 8. Very good. So that's your basic how to solve a proportion, which is great because if you can't solve it, you won't end up with your last piece. But now we have to figure out how do we set them up. And there are multiple ways to set up every proportion. So you really want to be consistent. I can be very scatterbrained. I tend to do 18 things at one time, so I really struggle with focusing at certain which is weird because in my strength quest, focus is one of my top 5. I find that very odd. But anyway, when I'm setting up proportions, I tend to label as I'm going in words because I find that if I write down what different pieces of the proportion represent, I'm less likely to make a mistake. Setting up proportions is about being consistent. If you have things all over the place and you're not consistent, then you can be able to cross multiply and divide all day long, but it's not going to be correct. So I want to talk through this one as I go so that you can see what I mean when I say I label things. So first, and this is a good rule of thumb when you're doing story problems of any type, read the problem first. Before you start to write anything down or punch anything into your calculator, simply read the problem, right? So Sally ran 4 miles to every 3 miles run by Billy. If Billy ran 254 miles in 2016, how many miles did Sally run? I can see right away that I'm comparing Sally and Billy, right? We're comparing how much these two people are running. So a proportion is about comparison. So I'm comparing two people. That's why I know I can write a proportion. And I'm going to say, okay, I have Sally and I have Billy. Remember, there's multiple ways to set this up. I'm giving you one. So I'm going to set up my proportion such that anything in the numerator deals with Sally, anything in the denominators deals with Billy. Now, they gave me a general ratio, so I'll just call this general. And then we talk about 2016, right? So when I talk about, let me put this in a box. The left side ratio, I'm going to make that my general ratio they gave me, and then I'm going to let 2016 be represented on the right-hand side. So you really, if you're going to do a label of here, you should be able to find labels for the vertical and the horizontal pieces of this. So let me change colors for effect, because why not? When I look at my general ratio, which is on the left-hand side, Sally ran 4 miles. Well, Sally, general, that 4 goes here. 3 miles run by Billy. That's still general. Billy's on the bottom. That 3 goes here. Then when I run over here, if Billy ran 254 miles in 2016, well, 2016 is on the right, Billy's on the bottom, so 254 goes here. This is my missing piece, and I'll call it X. You can call it whatever you want. I don't care. But the question, how many miles did Sally run? Well, that makes sense. That's what I'm looking for. I'm looking for miles of Sally in 2016. Once you have it set up, then you're ready to cross multiply. So I cross multiply and I get 3x. And I take 4 times 254, which gives me 1016. I want to stop right there. If you had set up your initial proportion in a different way, right? Because there are multiple ways to do this. No matter how you set it up initially, if you set it up correctly, when you cross multiply, you should have gotten 3x equals 1016, no matter which way you did it. So everybody's cross multiplication should be the same if your proportion is mathematically accurate. If you were inconsistent and jacked something up, well, then it's going to be different. But that's the key, is that if your cross multiplication matches you know, somebody else, you're probably right. And then just like in the last problem, we divide by 3 to get x by itself. This does not come out nicely. We're going to have to round. And we end up with roughly 338.67 miles is how many miles run by Sally in 2016. Questions by anybody on that particular problem? Okay. If you do, that's okay. Just feel free to put it in the chat box, but I'm going to have you try one. So go ahead and try this one. I'll give you a minute or two, and then we'll talk about it. All right, let's see what you came up with. Lots of different ways to do this. You might have labeled, you might not have, and you don't have to, right? You've got to find what works for you. I'm not telling you how to do math. I'm just trying to help you if you need some guidance. Some people really like to label because they like things to be crisp and they like to know what they're talking about. Some people want to just hold a calculator and do everything in a calculator. You've got to find what works for you and makes sense for you. I will never advocate for just hold a calculator and never write anything down, but I'm not going to judge you if that's what you do. Okay, so when I read this problem, right, we're talking about Cleveland to Columbus, and then we're talking about real life versus map, and then we're talking about DC to Pittsburgh, real life and a map. So I've got 2 different trips, right? I've got Cleveland to Columbus, and I've got DC to Pittsburgh. So when I'm talking about this is how I'm setting mine up. You can set yours up however you want. We're talking about maps and we're talking about miles, right? Real life. So Cleveland, Columbus is 140 miles and 1.5 inches on a map. DC to Pittsburgh is 5.5 inches. I got to make sure all my inches are together. How many miles is that? If your proportion doesn't look exactly like that, that's fine. As long as that when you cross multiply, you have 1.5x equals 770, your proportion is perfect. So let's stop there. Does anybody have any questions about their proportion did not yield 1.5x equals 770? Because in my answer key for this section, my proportion looks different than the one I just did in orange. I flipped things, and that's okay. There's nothing wrong with that. Mathematically, it's the same. I'll divide by 1.5, and again, we need to round, but roughly 513.3 miles from DC to Pittsburgh, roughly. Questions on that one? Going once, going twice. Thoughts, questions, concerns? Everybody doing okay? Okay. Oh, people are responding. That's always positive. Good. All right, so the last problem of section 5 that we're going to do is, I call it the what if game. I don't really think the packet gives it a, the what if game, but this is what we do. So there will be time where you are given information. So in this problem, we're making it up. Maybe there was a fundraiser, and in Michigan, they raised $16,500 and 250 people, and in Ohio, they had 300 people, and they raised $24,750. Great. That's information. Both states. This is what actually happened. Okay, so this is actual, just as we're talking through this. Now let's look at the problem. If Michigan were proportional to Ohio, the key word there is proportional. That means we can set up a proportion comparing the state of Michigan to the beautiful state of Ohio. So if Michigan were proportional to Ohio, how much money would Michigan raise? And I want to just draw your attention to that. So the question is, how much money would Michigan raise? Well, you'll notice we talked about money, we talked about people. So money and people would be the other labels if we're labeling. So how much money would Michigan raise? We're talking about Michigan, money. That's the unknown value because it's the what if game. What if Michigan was like Ohio? So sometimes with these, you almost have to work backwards and start with the what do I not know? Because if you look at what you're given all of the information. So we have to start with, okay, let's pretend that Michigan is as good as Ohio, and how much money would they have raised? Okay, so you put the X in. Then you fill in the rest with what you're given. Ohio has $24,750. Ohio has 300 people. Michigan has 250 people. Now I have a proportion with a missing piece, right? So this X that we're trying to find here is what Michigan should be or would be if they were like Ohio. Because we know what the actual is, we were given that to begin with. So we're playing the what if Michigan was like somebody else. Again, we cross multiply. So now we have 300x equals, turn the page, and we get 6,187,500. If we solve for x, what do we get on this particular problem? $20,625. Good. So that's what Michigan would raise if they were like Ohio. And then you would have a meaningful sentence. How does that compare with what they actually did? Well, so you can compare this, their would-be number, with 16,500, their actual number. Say, well, if Michigan was like Ohio, they would have raised an additional $4,125. So this is where people tend to get tripped up because, well, I already know how much Michigan has. Well, yeah, but now we're saying, what if they were as good as Ohio? How much would they have done? If you can't tell, I'm from Ohio, and when it comes to sports, I have a great dislike for Michigan. The state itself is fine. Okay, anyway. Does that make sense, how we talked through that, those problems, where they came from, all of that? Okay, so if you're given a problem and you look at it and you're like, I have all of the information, what are they looking for? Look at the question, because the question itself is where your unknown value of x is going to be in your proportion, and you can fill in from there. All right, good. Good. So I'm going to just start wrapping up. We're only in Module 2, and I understand that we have some time yet, but exam 1 is in Module 5, so it's 3 weeks from now, and it'll be here before you know it. So where are you taking? These are questions you need to ask yourself. where are you taking your exam? Do you know how to schedule that? Because that's on you. That is not on me. And if you don't schedule in time and you can't take your exam, then you get a 0. And I'm not very nice when it comes to that, because notice it's week 2 and we're starting to talk about it. So if you need help with this, you need to ask soon, not the day that the exam is due, because by then I've lost all interest. I will be posting a video in the announcements that hopefully you watch. It'll be how to schedule your exam in Ivy Learn. So if you have no idea how to schedule your exam, I recommend you watch that 1.5-minute video that will show you step by step in Ivy Learn how to schedule your exam. Okay, looking ahead, exam 1 is due on the 17th of February at noon. That's a Saturday. You have that entire week, Monday through Saturday, to take the exam. That's the only thing on the schedule that week. So I would recommend looking ahead. What day and time works best for you and scheduling that exam sometime soon, because you want to make sure you get the day and the time that works best in your schedule. And it takes a day for that to all be processed. So if you say, well, I'll take it on Saturday, so I'll just wait till that Friday to schedule. Well, if it's full, you're screwed. And if your testing center does not take Saturday exams, you're screwed. So I would very much recommend that you schedule this as soon as possible, or at least in the next week. Just had a question, can I take it in advance? Absolutely. All 3 exams are open. Technically, you can take exam 1 next week, exam 2 the week after that, exam 3 the week after that, and be done. I don't require you to stay with us. You're more than welcome to work ahead and take the exams when they work. We have due dates. Things cannot be done past the due date, but everything can be done in advance. So you can work ahead as much or as little as you want. Okay?
So then for that week, is that Wednesday's information that we go over going to be on exam 1?
The weeks of exams, our live sessions are question answer. So I have nothing planned for those weeks. It's basically whatever you need. So if you schedule your exam for Tuesday of that week and you're done and you have no questions because you're done, then there's no need for you to even log in on Wednesday. And you can then start your new material for the following week if you'd like. But if you're starting to, if you schedule your exam for Thursday, then on Wednesday, maybe you've gone through the practice test, which is also in Ivy Learn, and you can kind of let me know from there, where your questions are.
Okay.
Next week, we will be talking about where to find the practice test. There are 2 that you will be able to do. One of them, we're starting something new this semester, and I'd show you now, but they're not up yet. They should be live hopefully next week, knock on wood, where you'll be able to do it in Ivy Learn and get direct feedback, which will be very much like what the real exam looks like. So that will be very beneficial for you guys because you take the exam online as well. So I will go through that next week during this live session. It will be recorded for those who aren't here. But next week we will also talk about week 4 is when I will be in Houston on Wednesday. I'll actually be traveling during this time. So week 4, we will need to talk about an optional other time that if we want to have a live session that week, because I am not available on Wednesday at noon. So we will again have that conversation next week, because I usually do that a week out of when I'm going to miss. There are 3 Wednesdays this semester that I will not be available during this time. So we can either do them evenings on a different time or a different day at noon, or I can just post last semester's video, whatever you guys want to do. I can make that happen. So we'll talk about that next week as well. Yeah. Any other questions right now on anything we did today or exam 1? We'll definitely talk about exam 1 again next week because I want to make sure that we're all on board. Okay, I do have 2 more problems that I have ready, multiplying and dividing with scientific notation. Do you guys want to do those together or do you want to be done? I'll let that up to you. 2 more problems. Does anybody have a preference? Oh my gosh, nobody has a preference. Let's do it. I love it. All right, so and why not? So we're going to do 2 more problems, and if you don't care, feel free to leave, right? It's up to you. It's your world. But in section 3 and in section 4, I believe you are going to be dealing with a little bit of multiplying and dividing with scientific notation. They're not difficult, but it's good to at least know what to look for. And we will talk about significant figures a little bit here. That way, maybe web work won't be such a pain for you. So when you're multiplying with scientific notation, you kind of want to do it multi-steps. So you will see that each of these numbers has, that beginning piece. In 3.2, we call that 2 significant figures because 3 and 2 are each significant. Non-zero numbers are significant figures. There are times when zeros are considered significant, but we're not going to get into the details. 6.5 has 2 significant figures. That means my final answer should also have 2 significant figures. And I'm only bringing this up because in web work for section 3, it's going to deal with significant figures for your answers. They have videos with them, hint videos. So if you can't figure it out of what you need to round to, watch the hint video and it will explain it. Okay, so anyway, when I multiply 3.2 times 6.5, what do I get?
$20.8.
Why did I not get 20.8? Did I multiply wrong? Yep, I did. My paper's wrong. I must have multiplied. I bet I did 5.6. Yep, I did. I wrote down the wrong thing. Okay, so 20.8. Thank you. Very good. 20.8. I'm going to have to fix that on my answer key. Now, when I look at my times 10 to the blah, if I'm multiplying with the same base, what do I do to the exponents? I add them. Exactly. So 4 plus 8 is 12. Is this my final answer in scientific notation? Nope, you are all correct because 20 is bigger than 10. So if I move this one place over, what do I do to my exponent? Do I add or subtract? I add. Good. Because 20 is big. When you think big, big is positive, positive is up. So it's going to go up by 1. So I end up with 2.08 times 10 to the 13th. Now, mathematically, that is correct. But in web work, you would be counted wrong because remember, we need 2 significant digits. Right now, we have 3. So we'd start over here, 1, 2. Here's my 2 significant digits. I look one place past, and I look at 8. 8 tells me to round up. So my final answer in web work would be 2.1 times 10 to the 13th. Okay. So again, if you do the math correctly and you're frustrated, just watch the hint video. More than likely you watch one video and it's going to make sense and you'll get the rest of them right. Okay, but that's multiplying. And it's not always going to be the case that you end up bigger than 10. If you were multiplying 1 times 6, well, that's just 6. You're between 1 and 10 and you're done. So it does depend on the problem. Make sure you're just paying attention to the details. Okay, let's do a division problem. We've already done one division problem when we did the per capita, but that's okay. We've got time. We'll do this one too. So when you divide, right, you start with the numbers. And again, you'll notice that each top and bottom both have 2 significant figures. So my final answer will have 2 significant figures if you want to be correct in web work. All right. So when you take 2.5 divided by 5.6, what do you get? .45. Okay, so I'm going to use Vanessa's number that she did in there just so that we can show the whole world how we got the 0.45 where we're going to want to end up. So I got 0.446 times 10 to the what power? What's my exponent going to be? Fourth. Good. So remember, since we're dividing with the same base, we're subtracting. So 7 minus 3 is 4. And sometimes it will help if you talk to yourself. So if you remember, when I divide, I have to subtract my exponents, because the more you say it, the more you're going to remember it. Okay, if we're talking scientific notation, hopefully your ears perked up, because this 0.446 is not between 1 and 10. This is a small number. Small is negative. Negative is bad. Negative is down. So when I move this over 1 to make my number between 1 and 10, what do I do to my exponent? Do I add or subtract? I subtract. Very good, because it's negative, right? Down. So 4 minus 1 gives me an exponent of 3. Mathematically, that is correct. But I need 2 significant figures. So 1, 2, I look at 6, 6 rounds up, and we would end up with a 4.5 that I don't remember, somebody earlier typed in there. So 4.5 times 10 to the third would be your web work answer for that one. Okay, that is officially all I have for today. So sections 3, 4, and 5. Again, I will be posting the video for how to schedule an exam in Ivy Learn, and I'll be posting, I've already posted 2 help videos for web work homework, section 5. So if you get stuck, you might want to check there first. Otherwise, shoot me an email. Good communication coming from this class. That's super exciting. I'd rather over communicate than under communicate. So keep those emails coming. And yeah, let me know if you have any other questions. Otherwise, that is it for today. Thanks for participating. Later.